In the previous video, we looked at how to find vertical asymptotes for rational functions. In this video, we're going to look at how to find the horizontal asymptotes for rational functions. So what exactly is a horizontal asymptote? Well, the asymptote part is exactly the same. It is a line that the graph is approaching but never reaching. And a horizontal asymptote is a horizontal line, which means the equation is y equals a value. In this case, we're going to call it b. And it is a horizontal asymptote if the value of the function is approaching that value b as x increases or decreases without bound. So in other words, x is going to be approaching infinity or negative infinity. In the three pictures I put here, all three have x approaching infinity. I didn't realize that when I did it. It could also be approaching negative infinity. But as x is approaching infinity here, notice that he's coming closer and closer and closer to that line y equals b. But he's never going to touch it. And therefore, that is a horizontal asymptote. As x approaches infinity, the value of x, f of x, approaches b. Here is the second graph here is a graph of x approaching infinity again, but this case it's coming down instead of going up. It's coming down to the line b, but it's still approaching b. A third case here that I want to show you that is possible. I say that we're approaching a line and never touching it, but we're only looking at the part of the graph that is coming up to it, and that still binds it. It does not mean that he couldn't have ever crossed it like the vertical asymptote does. Okay, the vertical asymptote he can never cross, but a horizontal asymptote can sometimes actually cross the graph, just not in the area as we're approaching infinity. Now for the part that strikes fear into many students. It looks terrible, but what it's saying is really not nearly as bad as it looks. If you have a rational function, by definition, you have a polynomial numerator and a polynomial denominator. Instead of listing them as p of q or p of x and q of x, we've listed them here as polynomials, where the numerator is a degree n polynomial with coefficients labeled a, and the denominator is a degree m polynomial with coefficients labeled b. Notice that m and n, they are the degrees of my polynomials. So, why is that important? Because the degree of the two parts of the rational function tell me whether I have a horizontal asymptote and what it is. So first, if the greater degree is in the denominator, if the denominator degree is greater than the numerator, or if the numerator is less than the denominator, however you want to read that, then the x-axis, which is the equation y equals 0, is my horizontal asymptote. So if the denominator has a higher power than the numerator, y equals 0 is a horizontal asymptote. If the two polynomials are of equal degree, if they're both cubes or both fifth powers or both 20th powers, then the line defined by y equals the lead coefficient of the numerator's polynomial over the lead coefficient of the denominator's polynomial, that is my horizontal asymptote. And if the degree of the numerator is greater than that in the denominator, I have no horizontal asymptote. It's all about the degrees. So, for example, find the horizontal asymptote, if any. Well, in this case, I look to the degrees. Second degree, same degree, so the line y equals the lead coefficient of the numerator over the lead coefficient of the denominator, or to simplify that, y equals 3, is my horizontal asymptote. My graph here is not perfect. I see now that my little blue line was a little lower than I meant for it to be, But this is the general idea of that equation, that function, where y equals 3 was in fact the vertical asymptote of that graph. And for the function g of x here, I look for the degrees. This is an understood 1, so that's a first degree in the numerator, a second degree in the denominator. Because the denominator is of greater degree than the numerator, y equals 0 will be the vertical or horizontal asymptote of my graph. And this is the graph of G, with my x-axis, y equals 0, being the horizontal asymptote. And of course, the third case, where my numerator is degree 3, my denominator is degree 2, because the numerator's degree is greater than the denominator's, then I'm going to say there is no horizontal asymptote. And this is the graph of H. So again, the horizontal asymptotes have a nasty look to them, but they're really quite simple. It's all about the degree. If the degree of the numerator is greater, there is no horizontal asymptote. If the degree of the denominator is greater, the x-axis is the horizontal asymptote. And if the degrees are equal, then y equals the lead coefficient of the numerator over the lead coefficient of the denominator will be my horizontal asymptote.